Hello friends, today we will discuss nilpotent matrix. What is the nilpotent matrix? Nilpotent matrix is a square matrix which is said to be nilpotent matrix if it satisfied this condition for positive integer. The product of this positive integer equals to 0. K is known as the index of nilpotent matrix. Now let us define by the example. The example is that A equals to 0, 1, 0, 0, 0, 1, 0, 0, 0. Then we will take A square. This will become this matrix where the one identity only is entry is non-zero. Now when we take A cube, this will become whole 0. This will implies that the index of nilpotent matrix A is 3, right? Now what is the determinant of the nilpotent matrix? Determinant of the nilpotent matrix is positive. We know that A is nilpotent, so A to the power k is equals to 0. Taking the determinant A to the power k equals to 0, this will implies that determinant of A is equals to 0. So the nilpotent matrix determinant is 0. Now how to find the eigenvalue of the nilpotent matrix? Eigenvalue of the nilpotent matrix is known as when we have A to the power k is equals to 0. So by replacing A by lambda, which is because by application of Cayley-Hamilton theorem. So this will implies that lambda power k is equals to 0. This will implies lambda equals to 0. So therefore all the eigenvalues of nilpotent matrix are 0. Lambda equals to 0. All the eigenvalues are 0. This will implies that trace of A is equals to 0. Right? It is also implies the determinant of A is equals to 0. Right? Now second is that involutory matrix. What is involutory matrix? A square matrix is said to be involutory if its square is equals to identity matrix. This will easily say that A equals to identity, A is equals to minus of I. Right? These are the trivial cases. Now, if capital A is an involutory matrix, then A to the power n is also an involutory matrix. Right? How do we know that the eigenvalue? The eigenvalue is given by lambda square is equals to 1. This will give lambda is equals to plus minus 1. So lambda 1 is equals to 1 and lambda 2 is equals to minus 1. Right? There are two eigenvalues. And the determinant of this involutory matrix is positive 1 and minus 1, right? Either positive 1, either minus or minus 1. These are the determinant of this involutory matrix.